All right, so this one is going to be a related rate problem. So let's read very carefully and try to highlight the very important information that we get. So we have a 13-foot ladder that is leaning against the wall. So I'm going to draw it. That's the best way. So we have a wall. We don't know how tall, but we know that the ladder is 13 feet. And it's not changing in time. So here, any quantity that does not vary over time, you can actually just put them on the picture. If there's anything that changes over time, you cannot write a number. You are going to introduce a variable, but any quantity that are stay constants, you can just do it like this. So the base of the ladder is pulled away from the wall. So here it's like you're pulling it away. So as someone just trying to do a prank and just pulling the bottom of the ladder. And we are told that it is pulled away at a rate of 2 feet per second. And the question is, how fast is the top of the ladder moving down? So here, this is changing the wall when the top of the ladder is 5 feet in from the ground. So the best thing to do is just remember is to summarize into a table. So I'm going to do, so what vary over time, everything that vary over time, we're going to introduce variables. And remember, we're going to have the given rate. So it's going to be the, remember rate means derivative. So it's a prime. And then we are looking for a rate. So there's an unknown rate again. Rate means prime, derivative. And so we're just going to try to fill that up with what we're given. And then we're trying to, and then what we're going to be doing is trying to find an equation that relates those rates. In order to do that, we're going to relate the quantity themselves. So that's our table here. And so let's see about it. So how can we do that? So, sorry. All right, so what changes we see is the height of the ladder on the wall. So this is changing. So I'm going to introduce h for height, and also the base, how far the ladder is from, the bottom of the ladder is from the wall. So this, the base of that triangle here is also varies over time. So I'm going to call it B for base. And remember here we have a right triangle. So we're going to write B and H. Those are those quantities. And again, if I didn't have a picture, I will have had to define what B and H are for. But here it's very clear on my picture what B and H represents. Now, let's look at, so the given rate. So here, let's look at the problem again and read it. The base of the ladder is pulled away. So here, the base of the ladder is pulled away from the wall at a rate of 2 feet per second. What that means is that B, the distance between the base of the ladder and the wall, is changing and is increasing because we're moving it away from the wall. So it's going to be a positive rate. It's moving at a rate of 2 feet per second. So again, it is positive because that quantity here is increasing, and this is the rate of change of B, because that's how B is changing, so it's B prime. Now, what do we want? How fast? So that's how we are asking here. That's the question, that's the unknown part, is the top of the ladder. So the top of the ladder is the height of the ladder on the wall. So that's the H here. So how fast is how fast something is changing. That's going to be H prime here. And we want to find H prime, but not at all time. It's like we would take a snapshot and we want to know what's going on 5 feet from the wall. So that means here, when the top of the ladder is 5 feet from the ground, so that means when H is 5, that's the height of the ladder. So now here is basically translated all those into a little table here. We have all the information we summarized. Now we need to relate B prime and H prime. To do so, we need to relate the quantity themselves, in other words, B and H. And here we can see we have a right triangle. So as I said, usually when there's a right triangle involved, we will use Pythagorean theorem. So we have B squared plus H squared equals, and now here the hypotenuse is the length of the ladder, which is not changing, so it's equals 13 squared. So that is our equation. And so after that, once you do that, this is the hard part. It's always the same type of steps we have to do. We're gonna differentiate. So that's the first thing, summarize. Then we're gonna differentiate the equation we have with respect to t. So we have, I'm gonna take the derivative with respect to t of b squared plus h squared equals 13 squared is 169. So the derivative of 169. And so remember, any quantity that varies over time is like when we do implicitly the function of time. So when we take the derivative of b squared, it is a chain rule. So here it's going to be 2b normally, but because here the inside function is b, which itself is a function of time, that's a chain rule. So times the derivative of the inner, so it's times b prime. Same thing here, h is a function of time because it varies over time. So when it takes a derivative, it's a chain rule, and that would be 2h prime. And the derivative of 169 is 0. And now that we have differentiated, we can just substitute everything we have. So we have all information here. B prime is 2, it's positive. H prime is what we're looking for, and H is 5. And now we just solve. So here, sorry, that's number 4. So we have 4b plus 10h prime equals 0. And so we solve. So that gives us h prime equals minus 4b over 10, or minus 2/5 over times b. The problem is I really want a value, so I need to say, but what is b? I need to figure it out. So but how do I know that? It's not given. That is true. It is not given explicitly, but remember, we want to find a rate of change of the height of the ladder, how fast it's moving down the ladder at a spatial time is when the height of the ladder, the height against the wall is 5. So we want to find, what we need to do is say, well, we know that we want to know what's going on when h is 5. Remember, we always have the equation h squared plus b squared equals 169. So we can figure that out. And so means b is 12. So here the answer is going to be minus 2/5 times 12. So it's going to be negative 24/5 feet per second. So the answer here, let's conclude, the top of the ladder is moving down. That's what the negative here means, decrease. So h is getting smaller, is moving down at a rate of 24 feet per second, which is about, almost 5 feet per second. So we're just saying that that height is getting faster than how far you're moving. Kind of makes sense. So it's kind of, again, the order of magnitude, something you want to consider. But sign is very important here. You see it's negative, which makes sense, again, because the height of the ladder against the wall is getting smaller. So that's why we have a negative one. So